Welcome back, guys. This is Dr. RCB and you are viewing my channel Computer Science with Dr. RCB. This is part 2 of our video series where we are learning how to develop a web-based application using PHP, MySQL, JavaScript, CSS, and HTML. So you will, if you have not seen my first video, if you have not seen the first part of this video series, in that case, you can check that, you can get the link from the description, and then you can view that video first. Okay, that video is not a technical video, but I think that that video is important to get an overall idea about the application that we are building. Having said so, now let's move forward. Okay, suppose if people have seen that video and now you're here, so it is we are now ready to move forward. Okay, so in this part of the video, we'll be developing or we'll be creating the necessary database where we'll be storing this information. And later on we'll be using those database like here, as you can see in this picture. We'll be using that particular database that we create in this part of the video to connect from a PHP program. Okay, so we'll be using this database in the subsequent videos. So it is important that you go through this video, you create the tables, you create the database and the tables the way I do it here in this video. Okay, guys? Okay then. Now, before actually creating the database, let me tell you some basic things about the database, and like on what basis we decide like what are the tables that we have to create, and all these things. So now see here, if your application is very simple, like quite straightforward, suppose only one page is needed, in that case certainly all this information you can store in a single place and it is done. But usually what happens is when you develop an application, you have to keep track of many informations, you have to keep track of informations related to multiple multiple concepts. Say for example here, although we are like managing the information related to programs, but indirectly it is related to the information of the concept called the department, right? So it is not only the name of the department we might want to keep track of. We might want to keep track of some other informations related to a department. Say for example, what is the code of the department, or suppose which school that particular department belongs to, and some other information. Okay, so in that for that reason, what we might want to do is that instead of storing all this program and department information in the same table, we might want to store this information in multiple tables. That's just an just an intuitive idea, like why we might have to store this information not in one single table, but in multiple, but in two different tables. Okay, another thing that you should realize, like what is the problem that might occur if you store all this information, like department information and the program information, in the same table. Say for example, you consider this chemical science department. Okay, this is a department. Now let's say there are many different programs offered by this particular department. Let me do a search. Say for example, 4 years integrated BSc B.Ed major in chemistry. This particular program is offered by this department. And then integrated MSc in chemistry. This is also offered by the same department. MSc in chemistry. This is also offered by the same department. PhD in chemical science. That is also offered by the same department. Say for some reason later on it is decided that the name of the department should be changed from chemical science to, say for example, Department of Chemical Sciences. Okay, so in that case what one has to do is that he or she has to actually edit the name of the department in all these 4 or 5 different places. Like for all the programs which belongs to this chemical sciences department, everywhere the name of the department should be changed. Now, I don't say it is not possible or it is not doable manually, but the thing is that it always leaves some scope for human error. Like what I mean by human error is that, say for example, the person who is editing the name of the department, he or she has edited here it as Department of Chemical Science. Here it is a Department of Chemical Sciences. Here suppose department in small like DPT of Chemical Sciences, like that. So the same department name might be written in different ways at different places, right? So it leads you to some sort of inconsistent data. So to overcome that problem also, what we can do is we can break down this big table into some small tables. Like here it will be 2 different tables. One where we'll be storing the information of the programs, and another one where we'll be storing the information of the departments. Our goal is each department will be storing in a database. The information of each department will be storing in the database only once, and information of each program will be storing in the database only once. Okay, having said so, now it's time to actually create the database and the related tables. Okay guys, so for that reason, what we have to do is, first thing is that we have to open the gem control panel. Okay, and from there you see MySQL database here, this thing. Against this, if it is not in, like if it is not showing you stop, say for example it is showing you start, in that case first thing that you have to do is you have to click on this start button, and then this admin button will be activated, and then you have to click on this admin button. Now as soon as you click on admin button, you might not see this page actually. So as soon as you click on admin button, then you will see a page that looks more or less like this. Okay, now why did I write this number 8000, and how did I know that I have to write this number 8000, or do you also have to write this number 8000? It depends actually. You see here, when you open this gem control panel, you see that Apache is like listening to port number 8000. Like when I installed Apache, I specified that my port number where it will listen, where that particular web server will listen to. See here, this thing, this web server listens to a particular port. By default it is port number 80. So if during installation, if you change the port number the way I did it here, like instead of writing there 80, I wrote there 8000. So in that case, when you simply click on admin, it will lead you to this page. Okay, and that specific port number where Apache is listening to, you have to write it here. So for example, in my case, it is 8000. So I'm writing it 8000 here. Okay, as soon as you press enter, you will get these these web page. But if it is already 80 here, okay, you might not have to write anything, any number here. By default it is 80. So as soon as you click on admin, you might land up in this particular page. Clear? Okay, now this is actually, this page is giving you a graphical user interface to the database server. It means through this page you will be able to interact with the database server or with the MySQL server. Clear? Okay then. Now from here, first thing, let's do the simplest thing. The simplest thing is that we have to create a database for each application. It is usually happens that each application will have its own database. Okay, so for this specific application, we'll be needing a separate database. See here on the left hand side panel, if you have already created some database, then you will see, you'll get a list of all the databases that you have created. Okay, so let's create a new database for this particular application. So for that reason, what you have to do is you have to click on this new button. You have to give a name to the database. Say for example, student management, okay, or system. Student management system. I'm calling my database as student management system. That's all. You just have to give a name and click on create. One database will be created like this. See here, student management system is created. You click on this database, you will see no tables found in the database. What is a database? Basically, a database is nothing but it is a collection of some tables. So right now we don't have any tables inside this database. So after creating the database, the next goal is to create some tables inside the database. So how many tables we have to create for this simple application? As I said, no, like we want to keep track of the information of the programs, as well as separately we want to keep track of the information of the departments. Okay, so for that reason we'll be creating two tables there. Clear? Okay, now it's time now how to create a table. Okay, you can create the table from this graphical user interface. I'm sorry. You can create the tables from this graphical user interface. Like say, for example, you click on this student management. First, you have to select the database and then you have to click on this create table. That is one way of doing the thing. But I'm telling you the more technical way, okay? Like more like what? Programmers way of doing the thing. So it's a good idea that you actually know how to create a table. I mean, you know some basic SQL commands. Okay, like say for example, how to create a table, how to insert records into the table, how to retrieve records from the table, and all these things. So for that reason, what am I going to do is I'm not going to create a table through this graphical user interface. Rather, I'm going to write some commands that will do the job for us. Okay. Okay then. Let's first create our first table. So let me write the command here in a notepad. Why Notepad? Because I can increase the font size so that you can easily see it. So we want to create a table. So create table is the command. And then you have to give the name of the table. Say, for example, the name of the table is program underscore details. See, it is a name which is given by you. You know the variable name, it's just a variable name. The way you can keep any name to a variable, more or less, the same way you can keep any name to your database table. But the thing is that they should be meaningful. Later on, if you come back, you should just by looking at the name of the tables only, you should be able to know, okay, this table contains the information of the programs, this table contains the information of the departments, like that. Clear? Okay. Create is a keyword, table is a keyword. It means those two words you cannot change. I mean, you can certainly write create in this way. These are not case sensitive words, so you can write create in this way, no problem. But the spelling should be right, space, and then this table is another keyword, so it should be right. However, these are also not case sensitive in the sense that you can write table in this way also. And this is the name of the table which is given by you. So basically it could be anything. Okay, done. Now, not only that, like what are the other things that you might want to specify here? Create table. This is the name of the table. Along with that, you want a table is nothing but what? A table is nothing but a set of columns there. So you have to specify what are the columns that you want in your table. Okay, create table program details, and then you have to give a list of column. You have to specify a list of columns. Okay, the first column that we want is the ID of the program. So what we want to do is that each and every program we want to assign a number. That number will be calling as ID, and we'll make sure that that particular number is unique. It means no two programs will have the same ID. Okay, so ID, and then the next thing is, see here, this is the name of the column, and then you have to specify what is the data type of that column. Say, for example, the data type is integer. It means whatever the value you store in that column, all of them should be integer. Okay, and then I want this column, there is a keyword here you can write like auto underscore increment. It means what? Like whenever I store a new record or new row, whenever I create a new row in the table, then this ID field will get increased automatically. So it means you do not have to specify any value for this ID column. Automatically they will be, they will be filled up by the SQL server. Okay, so you will see examples. If it is the thing that you're seeing it for the first time, then I suggest you people to go to a particular website which is called as W3 Schools, like that, W3 Schools and SQL. Right there, you'll get this thing, SQL tutorial, W3 Schools. This is a good place from where you can learn all the, all the specific details about SQL. Okay, I'll not go through all these things. I'll simply talk about those commands that I'll be using in this project. Okay, guys, having said so, now let's go back to our command. So ID, this is the name of the column, integer is the data type, auto increment. This is an auto increment field in the sense that automatically the value of that field will be increased row wise. Like first row will have the number 1, then automatically the next row will have the number 2, like that it will go on. And you don't have to specify them directly, I mean explicitly. These are implicit values. Values will be implicit. What I mean by that, you'll come to know when I insert some records in this table. Okay, clear? Done. Now see, again, if you have any doubts or queries regarding all these, if people can write me in the comment section, I'll try to explain them in more details. Okay, done. This is your first column. After specifying the details of the first column, you have to specify the details of the second column. What is the second column that we want? Say, for example, the title of the program. And what is a title? Basically, it is a name, right? And what are names? Say, for example, my name is Dr. RCB. It is nothing but it is a collection of some characters. And if you have any programming experience, then you know that a collection of characters are nothing but strings. And the string equivalent in SQL is called as varchar. Okay, variable characters. You can think it that way. Okay, and also you have to specify the length of the string. Say, for example, the title of the program should not exceed 100 characters. So in that case, you can write varchar 100. Okay, now this is a keyword. You cannot write it in any other way other than varchar. Okay, however, these name of the columns, these are arbitrary. I mean, you can decide these names by yourself. Okay, clear? Okay, and title is done. Similarly, we also want to store the code of the program. So for that reason, code, and as you know, like it will be a varchar, right? Varchar. Why it is a varchar? Say for example, you can see here from this example, the code of the program is like CHB, MSB, PHB. All of them are 3 characters long, but they might not be. That is not a constraint that I want to put here. But my point is that the code of the program is like, again, a string. Okay. So for that reason, what we are doing is we are writing it code is a string, that is a varchar, and then the length of the code you can specify a maximum 10 characters. Okay. And also one more thing here, you people have to focus on is that the code of a program should not be duplicated. It means what? Say for example, the code for this particular program is CHB, then there should not be any other program that has the same code. That restriction is there, say for example. Okay, so in that case, what you can actually specify that restriction in the database level itself. So how do we do that? For that reason, you have to write here this thing, unique. Okay, so it means that this code is going to be unique in that particular table. That is, this code column, in this code column, no 2 rows will have the same value. You see here, suppose you assume that this is the table and this is the code column, in the sense that when you specify that this code is unique, it means that no two rows will have the same value in this column. It means if CHB is for this particular row, then you will not find any other row where the code value is CHB. You should not find it. Okay, so that restriction you can impose on the database by specifying this constraint, unique key constraint. Okay, you just have to write there unique, that's all. Clear? Then put a comma. See here, after each and every after specifying the details of each and every column, I'm putting a comma here. Okay, done. Code is done. And then the department. Now, as I said, no, we'll not store the information of the department in this table. So let's keep it aside. Okay, I'll talk about it later on. But before that, let's fill these columns like number of semester, graduation level, and technical level. Let's do them first. So number of semester, number underscore of underscore semester. It is an integer, and there is no constraint that I want to put here. Okay. And then graduation level, graduation underscore level. And this is, you can see from here, from this example, these are like varchar. Okay, these are some some characters, some strings actually. So varchar. This similarly, technical level will also be some strings. Okay, so graduation level varchar. I don't want 50 characters long. I just want maximum, say for example, 10 characters long. Okay, similarly, technical level. So I'm writing here technical level. Okay, done. Now only thing left is this department. So what we're going to do is, instead of storing the name of the department, what we'll be doing is we'll be storing here something called as department underscore ID. That will be an integer, and we okay, that much only. So for example, that will be an integer. Okay, now you will come to know like what this department ID means. Okay, so these many columns that we want in our table, and also we want to make sure here that in any database table there is a concept of primary key. That primary key is used to uniquely identify a specific row. You might be thinking, yes, code is like unique over the table, right? No two rows will have the same value for this code. You can use this code as a primary key. But sometimes what happens is that, okay, you might have to change this code. Like suppose, for example, okay, no problem, CHB is there, but later on, suppose this CHB, it is found that actually it is not CHB, it is something else, CHD say. So in that case, there might be some other table where you will be referring to this primary key of this particular table. So in that case, you have to sort of change everywhere. Okay, so to overcome that problem, I mean, if it is not clear, don't worry. So what we're going to do is we are not going to make this code as a primary key, rather we'll be making this ID a primary key. Okay, but certainly you can make this code a primary key and it will work fine. Okay, so I'll make this ID a primary key. So what I'll do is I'll write here primary key. Primary key is, these are like keywords. You have to write this word as it is. Which one you want to make the primary key? I want to make the ID as the primary key. Okay, so that's all. So this should be the command for creating the table. So if people now I'll do one thing, I'll copy it and I'll paste it. Now where from this notepad, certainly I cannot execute this command. So to execute this command, I have to go to this graphical user interface of this SQL database server, and there I have to click on this SQL tab, and there I can write command. I could have written the command directly here, but why did I write it here? Because I just wanted to show you the command in big fonts. Okay, maybe I could have done it here also, but then also okay. So okay, then this is the, and there is another advantage. Then when I want to create the next table, I will simply do a copy paste. So create table program underscore details. So basically we're creating this particular table, and these are the columns, like first column, comma, second column, comma, third column, along with some other details, like what is the data type of the column, if there is any constraint on the column, like this, or what is the primary key of the table, like that. Okay, so if the command is right, this is called as SQL command. Okay, if the command is right, then as soon as I click on this go button, that is, if you want to execute this command, you have to click on this go button. As soon as I click on this go button, the table should be created. Let's see. I clicked on the go button, and see, as soon as I do that, this table is created here. Now you click on that table, you will see, you will get this window. Actually, don't need to worry about what is this select star from program details. I'll be coming to that point, but before that, let's click on this structure and see the structure of the table. Okay, see the table that we just created. You can see here, these are the columns we specified against that table, right? Like ID, title, code, number of semester, graduation level, technical level, and department ID. Along with that, you can see against this ID column, the name of this particular column, you can see this yellow key that represents that this is a primary key of the table. This is the primary key of the table. Okay, and against this code also, the same key is shown, but in a different color. They're showing you index. So basically that indicates that, okay, that's a unique key. I mean, no two rows in that table will have the same value for this code column. Clear? Okay, then our table is created. Now our table whose name is program details is created, but still in this table, see here, if you think logically, in this table we are not storing the name of the department anywhere. You can see. But in our application, we need the name of the department, right? Right? Okay, so for that reason, what you're going to do is we are going to create another table whose name is department details. So I'm going to create this table, and I'm calling it, say, for example, department underscore details. Yes, right. Now ID, we need the same thing, will be the same concept. We want to assign each department an ID, which will be a number, and that should be automatically incremented row wise. Okay, and also we want to keep track of the name of the department that I'm calling here as title, and the code of the department. Each department will have some code. We are assuming it that way, and these things we do not need, right? I mean, up to the code part, it's okay. And also we want to make sure that these ID will be the primary key of this department details table. Clear? Okay, then once this command is ready, let's copy it and let's copy it and paste it here in this SQL. In this, as soon as you click on this SQL tab, it will automatically be filled up with one command, or like this command, or with some command. Don't worry about it, just delete it and paste it. So this will be the table which will be created as soon, this is the table that we want to create. If you think the command is right, then you have to click on this go button. As soon as you click on go button, see, you can see on the left hand side panel down here, the department details table is also created. Okay, now you click on the structure. You first select the table and then click on the structure. You can see, okay, ID is the primary key, title will be maintained, and code will be maintained, and where code will be the unique key for that particular table. So our two tables are ready. Then let's now try to insert some records there. Okay, just check like how we can store data there, how we can retrieve data from the table. Okay, now to store data, say let's first store some departments. Okay, because you see here to create, think logically here at this point, to create any program, first thing that you have to specify is what is the department that offers that program. Department is the mother table you can think of, and program is the sort of child table. Okay, without department, program cannot exist, but without program, department can exist. Logically, if you think it, this would make sense. Okay, okay then. Now let's okay, before actually storing the data on the same line, when I said like without department program can exist, or sorry, without program department can exist, but without department program cannot exist. What does that mean actually? You see, from the program table I said like department ID is an integer. This department ID, see, against each program will be storing the department ID. So for example, if there is a department called chemical science and there is a program called MSc in chemical science, so against that record like MSc in chemical science, we will be storing the department ID number, that ID number for the department chemical science here. What I mean by that, I mean that's a connection. You see here, basically it's a connection. I mean this particular column is actually pointing to a specific row of this particular table. You got it? This is called as a foreign key constraint. Although I didn't specify the constraint directly here, but ultimately it is the foreign key constraint. If you people need more detailed video on these concepts, please let me know. I'll stop. I mean, I'll not go further. I'll not explain this concept in this series of video. I'll not explain these concepts. I'll not go in that direction. Actually, I just wanted to show you how to create a table, what are the structures of the table, and that's all. Okay, but if you need some detailed explanation, then if people can write me in the comment section, I'd like to do help you people. But here I'm just trying to give you an intuitive idea behind this structure, like what intuition actually you should follow to understand at least the structure of these tables. Okay, then having said so, now it's time to insert some records there into the table. As I said, no, department is the mother table sort of, and the program details are the child table. It means without department, programs cannot exist. Logical things, huh? It's just pause and then think. It should make sense. Until and unless it makes sense, don't go further. Just kidding, you can, no problem. Okay, then now next point is that you should insert some records into these tables. Okay, let's do it. So to insert records into the table, you have to use this command, insert. You could have done this from the graphical user interface, but I don't prefer that. As a programmer, you should know these commands. Okay, so for that reason, I'm doing this. Insert into, these are keywords again. Insert into which table you want to insert the data. You want to insert the data into department details. So insert into department details, and then you have to specify the columns against which you want to insert the data. Now you see, I made this ID column for this department. I'm trying to insert some record or rows in this table department details. So I have to specify the values against each of these column. Yes, true. But the thing is that since I made this ID auto increment, I don't have to explicitly specify the value for this ID column. I have to specify the values only for these three columns. Okay, so let me write it in this way. I'm trying to insert the values. I'm trying to insert a row in this department details tables, and then values that I'll be specifying against this column, title, title, title. Here they should be same as the column names. Okay, title, comma, code, comma, that's all. Title and code, that's all I have to insert. Now see, they need not to be in the same order. What I mean by that, you could have easily written it like code comma title. That's not a problem. Code comma title. Okay, done. It means the meaning of the command is that we're trying to insert into this particular table against these two columns. Okay, why didn't we write this ID column? Because it is an auto increment column. It means values will be inserted against this column automatically. Okay, done. Insert into this column against these two columns. We want to insert the values. So what are the actual values? That also you have to specify. So you'll be writing this keyword values there, and then you'll be specifying the actual values. Now remember one thing here. If you are specifying the values for a string, that is a varchar, you have to write them within this single quotation. If you are inserting the values for a number, like say for example that you will see number of semester, then you don't have to write this single quotation. Okay, so for the time being, what you have to remember is that if it is a string that you are trying to insert, then you have to write them within this single quotation. Okay, and then comma, another string. So the first string should be the code of the department. Say for example, physics department, PHY. Why the first string should be the code of the department? Because you specified it that way. The same order you have to, here you have to maintain the order. Like if it is code first, then the first value will be code. If it is title second, then the second value will be title. However, these orders should not be same as the actual order of the columns in the table. Do you understand that point? I guess so. Right? Okay. Now, code PHY title, say Department of Physics, say Department of Physics. Okay, done. You can insert multiple columns at the same time. So you can write it in these values. I'm just, see here, you could have written everything in the same line. Just to make it more readable, I'm just writing them in separate lines. Okay, this is my first row. This will be my second row. Say for example, next one is chemistry, CHM, okay, or CHB, Department of Chemistry, Department of Chemistry. What is the spelling? CHEM, Y or I, YS, no, ISTR. I'm sorry, I usually forget these spellings, okay? You know, like say for example, you're typing in Grammarly, you're typing in Google Docs, then really you don't need to remember those. But it's a bad idea actually. I'm sorry for that. Okay. Okay. PHY, and I'm just arbitrarily giving these department codes. Okay. Done. And what else? Say for example, let's insert one department for my own department. Say CSE, Department of Computer Science and Engineering. So let's call it Computer Science and Engineering. Or it could be any department. Say we want to insert 3 rows against that department. So we'll write the command in this way. Now, since the command is ready, so we can now execute it. So what I'll do is I'll copy this command from here and I'll go to this SQL tab here, and whatever it is there, I'll delete them and I'll paste it here. So if the command is right, as soon as I click on this go button, it should be 3 rows should be inserted into this department details tab. Okay, let's do it and check. I'm clicking on go. 3 rows are inserted. Department details, if I click now, as soon as I click on this department details, you'll be able to see, okay, 3 rows are inserted. See here, I didn't specify any values for this ID column. Since it was mentioned as auto increment, automatically each row will have these values starting with 1, 2, and 3. Certainly, you can start from any number. There is a way of doing the thing. If you want to know that, you just do a Google search, you will come to know. But the idea behind this auto increment field is that it will assume a starting point, and from there, automatically all these values will be inserted. The next row will always have, have one value. By default it is 1. This like 1, then it is 2, and then 3. It might go like 1, then 5, and then 9, like that also. That is also possible. Okay, you got the point? Clear? Okay. Now you can see that as soon as I executed that command, 3 rows are inserted. Exactly the way I specified it here. Right, except an ID field. And why the ID field is automatically inserted? Because it is an auto increment field. Clear? Clear. Okay, done. Now, since we have now some departments, then we can create some programs which are offered by these different departments. Okay, let's do it. Okay, so we'll be doing the same structure actually. Okay, so insert into program details. Okay, and I could have written it in the same line, but just to make it more readable. So what is the next thing that we have to specify? We have to specify the columns against which we want to insert the values. So ID we do not have to specify because it's an auto increment field. The next one was title. Again, I'm saying you they should not be in any order. For example, I can easily write like number of underscore semester. You have to write them right, huh? Like say this is number of sem is written that way, so I have to write it in this way. Sorry. So this number of sem first column. The second column is graduation level. Next one is say for example technical level. Next one is say for example title. Next one is say for example code. That's all. 1, 2, 3, 4, and then 5, and obviously one important column I forgot, and that is your department underscore ID. Okay, you have to specify like which department that particular belongs to. You'll be writing here the ID. Okay, now okay, let's first these are the columns against which you want to insert the values. Let's just count the number of columns. 1, 2, 3, technical level is 3, then title 4, code 5, department ID 6. Total there should be 7 columns. 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, this one is not a column, so 7. Okay, right. Done. So against these columns we want to insert some values, so you have to specify the actual values. Okay, so the first we'll be inserting multiple rows. So the first row will be number of semesters, say for example 8. Graduation level, say for example it's a string, that's why I'm writing here graduation level is UG, and number of semester is not a string, it's a number, integer, that's why I'm writing here 8 directly, not within any quotation. And then graduation level and technical level, say for example BTech. See here, these are like as I said, based on the requirement, we came up with these whether we'll be like, okay, you might be thinking like why we are maintaining this information of graduation level and technical level against a program. That actually is that came from a requirement analysis. In your application, suppose you are developing an application, you are developing a student management system of your own. It might happen that actually you don't have to keep track of graduation level or technical level. That is, you don't have to assign any graduation level to a program. You don't have to assign any technical level to a program. Here, I'm just showing you an example. Just, most probably you got the point, right? Yes. 8, and say, for example, graduation level is UJ, technical level is BTech, and title of the program is, say, for example, BTech in computer science and engineering. ENGIN. I usually forget the spellings, don't mind for that. ENGINEERING. Okay, and title is done. Then code is, say for example CSB, and say department ID. Now it is important. I cannot write any arbitrary value for department ID. Okay, I have to write here some number which exists in this particular table. Okay, so if PHY is 1, CHB is 2, and then CSE is 3, so in that case, from the name itself, you can make a guess like which department is offering it, computer science and engineering. So I have to write there a 3. Then the first row is the values for the first row is done. 1, 2, 3, 4, 5, and 6. Total should be 7 actually. Number of semester, graduation level, technical level, title, code, and department. I guess I'm right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, done. What about the next row? Let's copy it and paste it. Say next row is, say number of semester is, say for example 4. It is a in a post graduation course, say for example, and it is, say for example, what I call it, say MSc. The name of the sorry, technical level, not technical level, say for example, what I do, say masters. I'm just writing some numbers there, okay, some values there, and the name of the program. Say for example, name of the program is a master's in chemical sciences, SCIE and C, chemical science. Okay, and then say for example it is M, masters in chemical science. What it could be, M MCE, say, okay, the code of the program. I'm specifying it, Masters in Chemical Science, MCS, for example, and the department ID. Which department offers this particular program? Say chemistry department. So 1 and 2. So 2 will be the department ID. Done. So these are the two rows that we want to insert, say, for example, in the table through these SQL commands. Certainly, we'll be rest of the rows we'll learn like how we can insert them through this program. Actually, our ultimate goal is that to create a user interface like this. We don't write those SQL commands by ourselves. The user will not write those SQL commands by themselves. They'll just specify the values here, and done. Automatically, the rows for the program details will be inserted into the table. And again, to insert some new rows to the department table, then certainly you have to create a different page that will allow you to edit the details of the department like this. Okay, so that page will give the functionality to the user, like from where the user will be able to, like edit and add a new department, delete an existing department, edit the details of a particular department like that. Okay, but our video is on this particular specific program, editing the details of a particular program. So we'll be sticking with it. Okay, don't mind. So department information we'll be inserting like manually, and for this program information certainly we'll develop this page. But just to show you examples like how we can insert records into the table, I wrote this command, and suppose our command is ready, and in that case what we can do is we can go to SQL, delete whatever it is showing you right now, and just paste it here. Just go through the command, and I think it is right. Now I'll be clicking on go button. Done. So 2 rows should be inserted in program details. Okay, now you see ID, and this ID field is automatically inserted since it is an auto increment field, and the title of the program, code of the program, number of semesters, and graduation level, and technical level, and department. Clear, right? Okay, now we saw how we can create tables, how we can insert records into the tables, and then the next question is, as I said now here, we do not want to see, although we have stored the information in 2 different tables, but the thing is that here we do not want a button like, okay, click here to get the details of the department, right? The ID of the department is, say, for example, 4, and click here to get the details of the department. Those sort of things we do not want. We want all this information in the same place, on the same page, as if, as a single table, basically. Like when we view them, we want to view them as a single table, but when we store them on different tables. And see the advantage now here. Now suppose if like storing this information on different tables, what is the advantage? Suppose someone wants to change the name of the department of computer science, say for example from computer science and engineering to department of computer science and engineering. He or she can directly edit the value here. Immediately it will be reflected against all the programs that is offered by this department. See, the name of the department is stored exactly in one place, and that's all. If any changes are needed, then we have to do it here. Clear? So those sort of advantage we get when we store the information in some normalized tables. Okay. Okay, then having said so, now as I said, now the next point is that we do not want our information to be displayed in a broken way. Like as I said, I do not want a button here that says, okay, click here to get the details of the department. When we view the information, we want to view them in a single table. However, when we store them, certainly we'd like to keep them on different tables just to, get just to reduce the redundant information storage, just to reduce the inconsistency in the information that we store. So to overcome those problems, we splitted them, right? But while viewing them, certainly we want to view them on a single page or as if they are coming from a single table. Then how do you do that? To know that, these are quite straightforward things I'm going to tell you now. That's not a big deal actually, okay? It's possible. How do you do that? Okay. To do that, actually, first thing that you need to know is that how you retrieve values from a specific table. So for that reason, what is the command to do that? The command to do that is select command, select. Okay. Now this select command, let's see the structure of the select command. Select, and then most commonly people write like star, select star, then this keyword from, then you have to specify the name of the table from where you want to retrieve the details. So you can write like select star from, say, department underscore details. Okay, and later on you'll be writing, there is another part where one, for the time being you'll see it like this. Okay, now select is a keyword, from is a keyword, and this department details, as you know, like it is not a keyword, it is the name of the table from where you want to retrieve the data, and where is a keyword, and one, for the time being you'll write it as one. Now let's see what is the meaning of all this. Okay, this star means, this star actually represents all columns, and this where one means all rows. Okay, so ultimately what this command is doing is that select all the columns from this department and also show all the rows. Is it so? Okay, then let's execute this command and check. So what I'll do is I'll go to this SQL tab, and by default it is actually written like this. Now see, select star from, because this is the table which is currently being selected, so that's why select star from department underscore details where one. But then also let me delete it and let me paste the command that I actually wrote in the notepad. So it is like select, I can, I guess, increase the font size here itself. Okay, instead of doing it like writing there and copying it. Okay, select star from department details where one. This star represents all the columns, this one represents all the rows. Now if I execute this command, now the problem is now what? Yes, I have to scroll. Okay, no problem. To execute this command, I just had to click on that go button, and as soon as I click on go button, see, against this command, like when I wrote select star from department details where one, all these rows are retrieved actually, isn't it? All the rows, see, this star means all the columns, means all the columns of the table, like ID, title, code, and this where one means all the rows will be returned, like first row, second row, and the third row. Clear? Okay. Now, if it is the case, then suppose we do not want all the columns, we do not want all the rows. Yeah, it is possible. So if you do not want all the columns, then you can do one thing here. You can write the name of the columns explicitly there. Okay, these are the columns that I want to see on the output. Okay, say for example, I just want to see the title of the department. That is select title from department details where one. See, all the rows I want to see, but I do not want to see all the columns. I want to see only the title column. Okay, okay, if it is the case, if it is your wish, then just click on go button, write the command, click on go, you'll see only the title is being displayed here. Simple basic SQL, I'm telling you. Okay, okay, done. Now if that is also done, then let's talk about this where one clause. Suppose we now don't want to see all the rows, we want to see some specific rows. So if it is the case, then you have to write there some condition. Say for example, where title, or say where say for example code is equal to CSV. So it will show me only that particular row where the code field is equal to, or the value of the code column is equal to CSV. If there exist any rows, that will be displayed. Okay, so if I click on, see here, this is my command, it will show me the title. I am interested only on the title column of that specific row where the code value is equal to CSV. Okay, so as soon as I click on this go button, you can see 0 rows are returned. Why? Because there is no department whose code is CSV. Okay, then let's make it CSE. Let's see what it is returned. So in that case, you can see it has returned like one total. One row is returned, and that is this specific row. Why only the title column is being displayed? Because you specified that thing that way. Select title from this thing. Suppose you want to see all the columns for that particular row. So we'll be writing there select star from this, and then we can go. Now it is showing you all the columns for that particular row where the code is CSE. Okay, done. So that is the that is how you retrieve the details, or you retrieve information from a particular table. So now you should be able to at least think, although we are not doing it right now today, so you should be able to think like what is happening when I refresh this page. Okay, as you know, when I refresh this page, actually what happens, a request goes to the web server asking for a specific page. Say for example, the page is edit program details. Now, what that edit program details page is ultimately doing, it is connecting with the database. In the database, it is somehow executing a command like select star from program details where this is equal to that. And whatever it is returning, it is actually sent back to this, this client machine. Can you connect that point? You don't need to worry about it, even if you cannot think about it. But I'll be coming to that point certainly. That's my goal here. That's our goal here, to learn the entire process. But then also, I'm just telling you, you should be, you should be able to think that way actually. Now, ultimately, what is happening here is that program will execute a command that looks more or less like this, not exactly like this, right? Still, I yet have to tell you one more point here. See, whatever the data that we are retrieving here, they are coming only from one table. But what if we want data from multiple tables? Because here, whatever these information are coming, they are not from one table. They are like, coming from two different tables, at least, like the program details and the name of the department, right? So how do you do that? So the command is again very simple actually. Instead of writing one table name here in the command, you can write two table names also. Say for example, let me zoom in a bit. Select star from, then you write not department details only. You also write select star from department details, comma, program details. Or you can write, say, program details first. No problem. You can write any one first. That's not a problem. But I'm writing here select star from program details, comma, department details, where 1. As soon as I write, and suppose this is my command, because I want to see all the columns from both these tables and all the rows. Okay, now what I mean by that, I mean how it will be displayed. Let's see. As soon as I click on this go button, let me zoom out a bit. If you can see it, you can see all the columns are displayed. Like this is the ID of the program details table, title of the program details table, code of the program details table, number of semester of the program details table, graduation level, technical level, and department ID of the program details table. These columns are from the program details table. And the rest of the columns like ID, title, and code, they are from the department details table. But if you see, like how many rows are written, like 1, 2, 3, 4, 5, and 6. But if you remember, in our program details table, we had 3 rows. In our department details table, in our program details table, we had 2 rows, and in our department details table, we had 3 rows, right? But how come this table has these 6 rows? That's a question, isn't it? Yes. Now see, although it is showing you 6 rows, you can, if you read these rows, then you will see that all the rows are not valid actually. See, for example, BTech in Computer Science and Engineering, these are okay. But this ID, department ID is 3. Now this particular row is combined with Department of Physics also. This BTech in Computer Science and Engineering is also combined with Department of Chemistry also. BTech in Computer Science and Engineering is also combined with Computer Science and Engineering. So out of all these 3 different combinations, you can see BTech and Computer Science and Engineering combined with Physics, BTech Computer Science and Engineering combined with Chemistry, BTech Computer Science and Engineering combined with Computer Science and Engineering. Out of all these 3 combinations, you should realize that only this particular combination is valid. This combination is invalid. Right? I mean, this one is an invalid combination. This is an invalid combination. This is also an invalid combination. Clear? Now, how do you know which one is valid, which one is invalid? You can say that, okay, BTech Computer Science and Engineering must be there in Computer Science and Engineering. That's okay. Human level, we can do that. But can you come up with a more, more solid checkpoint there? I mean, if you can, then let me know it in the comment section. I'm going to reveal it in a moment, but then also if you could already figure it out, then you please let me know it in the comment section. Okay, the point is that you can see here the BTech in Computer Science and Engineering, the department ID is 3, and this is the ID of the department. So whenever it is a valid combination, then both these 2 numbers will be same. Yes, it is valid, and these 2 numbers are same. This is not valid. See, BTech in Computer Science and Engineering, department ID is 3, but it is combined with some other department whose ID is 2. Here, department ID is 3, it is combined with some other department where ID is 1. Here, the department ID is 3, but it is combined with with the actual department whose ID is 3. So it's a valid combination. This one is invalid and this one is invalid. So similarly for this 2, it is combined with 1. No, it's not a valid. 2, it is combined with 2. It is valid. 2, it is combined with 3. It is not valid. So when you simply write program details comma department details, technically speaking, what it is doing is that it is performing a Cartesian product of the left hand side table as well as the right hand side table. Cartesian product of set. So if there are like in program details we had 2, in department details we have 3. So 2 multiplied by 3 is your 6. So that's why 6 rows are coming. But out of all these 6 rows, only 2 of them are valid, right? So we know which rows are valid. Then how we can filter these valid rows from those invalid rows? That's a question now. If you think for a moment again, if I give you 1 minute, 1 moment, then you will be able to find it out actually, because you know how to select a how to select a specific row or a set of specific rows, right? Just by writing some condition in the where clause. Okay, let's do that. Okay, so what where clause should I write here? So again, I'm asking you, like, if you can figure it out, you can let me know it in the comment section. I'll come to know actually. That will give me some idea about my viewers. Select star from program details, department details, where what we want is where you can directly write here now where department underscore ID is equal to the ID. Okay, or you can be more explicit actually, where program details dot department ID is equal to department details dot department details dot ID. You can explicitly mention them that. Okay, so as soon as you do that and you click on this go button, you should be able to see only the valid rows will be displayed to you. Only the valid rows. See, all the columns, no problem with that. But masters in computer science, what is the corresponding department name? Masters in chemical science, what is the department name? Department of chemistry. BTech in computer science and engineering, what is the department name? Computer science and engineering. See, valid combinations are being displayed, right? Now, almost done. This video is almost over. Now, one more thing, the final thing is that, see, instead of writing this program details too big, no, as a name, it will require you lots of typing. So what you can do is you can use some shorthand notation like this. Select star from program details as program details. This type of notation I'll be using in the upcoming videos also. That's why I'm telling you. Select star from program details as PD. It means I'm giving a short name for this particular table. Similarly, department details as, say, for example, DD, wherever now I have to write program details, I can write PD because I assigned this small name to this big name. And wherever I have to write department details, I can simply write DD. Okay, it will return me basically the same output. I click there, you can see this. So you might not be interested in all these columns, right? So now you know how to do that, right? You just have to specify, instead of writing this star, you just specify, okay, select pd dot, say, code, comma, pd dot title, comma, pd dot number of, that means you can give a small name to a column also, okay, pd dot number of semester, comma, say, department details dot title. Okay, only 4 rows. Okay, the code of the program, title of the program, number of semesters in the program, and the title of the corresponding title of the department that offers that particular program. These are the columns that we want to see in the output. So let's write the command that way and click on go. You'll be able to see these output here. Yeah, code is this, title is this, number of semester, and department name. Okay, all right. So that's how. Now in SQL level, I think things are clear. I mean, these commands we are going to use now specifically not for creating the table, but when we want to retrieve data, we'll be using commands like this. Okay, clear? Let me show you another command that we'll be using from our program. Okay, that is your update command. So just final command, okay, and I'm just showing you, okay, these commands we'll be using, so you can get into the details of these commands, as I said, from that W3 Schools video website, if you want a detailed understanding of the thing. But even if you do not go through them, only this much, then also it will work fine. I mean, you'll be able to follow my videos, no problem. Okay, then our final command is this update command. Okay, so for that reason, what we will be doing is, say for example, we want, say, department details. Okay, now here, say for example, department of chemistry. The code of this department of chemistry we want to change from CHB to, say for example, CHD for some reason. Okay, how do you do that? Through some SQL command. Directly you can edit it here graphically, but not that way, because what we want is, ultimately we want, why do not we want to do them graphically? Because see, we want those things to be done by some program. So through this program, if you want to do them, if you want to update anything, if you want to select some data from the database tables, then certainly those commands you have to write here in this program. That is, from this program you should be able to issue those commands. Okay, and that's why you need to know the commands to do the things. Clear? Okay, now let's do our final task here. Suppose we want to change the name of this code, that is the code of this department of chemistry, from CHB to CHD for some reason. Okay, so let's see how to do that. The command is simple: update the name of the table, update what is the department underscore details. Then you have to set the code of that. You want to set the code to be, say for example, CHD. For which row you have to specify. If you simply write set code equal to CHD, then it will set the code for all the rows, but we do not want that thing to happen. So what we want is, we want to specify, okay, set the code for CHD against which row, where code, wherever you find the code as CHB, you change it to CHD. That's, you know, that's like one instance of writing this, one example of how to write this update command. Okay, but there are different ways based on the situation. You'll be using this command in different ways. So if you want, again I'm telling you, if you want to know, get into details of all these SQL commands, then W3 School is the best thing and a best resource there. So you can go through those simple examples there and you'll understand them very easily. Okay, done. Okay, now this command should change the code wherever it is CHB, it will change them to CHD. Okay, let's do it. As soon as I click on go, one row is affected. It means the command is successful. Let's see it now. As soon as I click on department details, this command is getting executed automatically. As a result, you can see all the rows from department details is being displayed, and CHB is now changed to CHD. Clear? Okay guys, then so that much only in this video. So in this video, what we did mainly is that, although along with like giving you some explanation, certainly I mainly from the point of view of the project, we created the database needed for the project, and also inside the database we created these two tables where we are going to store some information. The rows in this program details table we want to store from some program. However, in this application, whatever the department details we have to store them manually like this. Okay, clear? Okay guys, then that much only in this part of the video. If you have any queries or doubts or anything, please let me know it in the comment section. Okay, so see you guys in the next part of the video. Till then, have a nice day.